Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will do some chemistry and today we will cover strong acids and weak acids for GCSE chemistry. Now I will explain what strong acids are, what weak acids are, and I will also help you understand the difference between the strength of an acid as well as concentration of an acid, because those two are two different things. Okay, now if you get confused by this video and you have no idea what I'm talking about, be sure to check out the link in the description below where I have a video about basics that you need to understand about acid and bases before understanding this video, so be sure to check it out. Okay, without further ado, let's get started. First of all, as I already mentioned, acids produce protons in water. So, as soon as we add an acid into water, so here we have hydrochloric acid, it splits into positive hydrogen ions, in other words, protons, because hydrogen ion is a hydrogen atom without the electron, essentially leaving a single proton. So H plus is a proton. Okay, so if we put hydrochloric acid in water, it splits into protons and negative ion of chloride ions. And another example is sulfuric acid, where if we put in sulfuric acid into water, it splits and dissolves, it dissociates into two protons and sulfate ion. Okay, so for example, if we had a cup with water, like so, and we put in HCl, then we would have H plus ions swimming around, we would have Cl minus ions, H plus, like so. They would just be swimming around in that cup. And that's how acids work. And that's, as we covered before, that's how pH works. Because pH is a measure of H plus ions. So the more the H plus ions there are, the lower the pH. The less H plus ions there are, the higher the pH. So this is how acid works. Now, we have two different types, strong acids versus weak acids. So far, you probably have covered strong acids. Examples of strong acids are hydrochloric acid, sulfuric acid. There is also an acid called a nitric acid. That's also another example of a strong acid. Now, what about weak acids? An example of weak acid is ethanoic acid, for example. I will put them down for you. So let's go over examples first. I will explain exactly how they work, but let's just cover examples first. So, strong hydrochloric acid, which is HCl, sulfuric acid, H2SO4, nitric acid, I think is HNO3, and so those are examples of strong acids. Now, what about weak acids? One example of weak acid is ethanoic acid. So this would look like this, CH3COOH. Okay, so those are examples, but what's the actual difference? What's the actual difference between strong acids and weak acids? Well, as we already said, acids produce protons in water. Now, with a strong acid, so let me just draw quickly a cup. So we have a cup of a strong acid, like so, with water. And a strong acid, example of a strong acid is hydrochloric acid. And we put hydrochloric acid into that cup. And what happens, like I already said, it dissociates into these ions, hydrogen positive protein, the protons, and the negative chloride ions. And the important thing here is that every single HCl molecule that goes into water will split into those ions, every single one of them. So we could write this down like so. HCl goes into water and splits into H plus Cl minus. So that's actually what happens in the strong acid. Every single molecule dissociates in water. Every single molecule splits into ions in water, and that's what's crucial about strong acids. So that is strong. Now, what about weak acids? What happens in weak acids? Okay, so let's take example of ethanoic acid. So we have a cup of, again, cup with water, and here we are putting ethanoic acid. So we are putting CH3 COOH. Now, putting that in, and what happens now? Well, it splits into protons, and it splits into ethanoate ions, CH3COO minus. So that's the negative ion, and that's the proton. However, that doesn't always happen because it's a weak acid. In weak acid, we do not get a full dissociation. Not every single molecule that goes in there will split. Some of them will stay in their original form, like so, CH3COOH. Some of them will stay in their original form and they will not split. And some of them will split. And that's the difference between strong acid, where every single molecule splits into ions, and weak acid, where only some molecules that go into water split into the corresponding ions. Now, how would we write down the reaction here? Well, very similar. CH3COOH. And on the other side of the equation, we have protons, H plus CH3COO minus. So that's how we would write down the reaction. But the difference is here that this essentially is an equilibrium reaction, where some of that acid forms these ions, whereas some of it doesn't. It stays in its original form. And hence it forms this kind of an equilibrium, which we can of course affect, but that's a topic for another video entirely. So that's the difference between strong acids, which dissociate completely. They split into ions completely, whereas weak acids do not dissociate completely. They don't split into their corresponding ions completely. So this is a weak acid. Now, okay, so now if we have two acids at the same concentration, if we have two bottles of acid at the exact same concentration, then, of course, the logic tells us that strong acid would have lower pH than the weak acid. And that's true. If we have two acids at the same concentration, strong acid has a lower pH than the weak acid. But this is only true in cases where the concentration is exactly the same. Now, what am I talking about here? I will explain you the difference between concentration of acid and the strength of acid. Okay, so here we have concentration versus acid strength. Okay, so what happens? What happens in the pH? pH, as we already covered, is a measure of how many H plus ions we have in a given solution. If we have a lot of H plus ions, we have a very low pH. If we have very few H plus ions, then the pH of the solution will be, of course, higher. Now, the important rule here is that the H plus concentration changes by 10 to the power minus x when pH changes by x. So, for example, if pH changes by 1, then if pH falls by 1, so if pH changes by minus 1, then the concentration of H plus ions will change by 10 to the minus 1. So it will change by, essentially it will turn to 10 to 1. So concentration of H plus ions will change 10 times. It will increase 10 times if we decrease pH by 1. If we increase pH by 2, then it will the H plus concentration will increase by 100 times. If we decrease pH by 3, the H plus concentration will change by 1,000 times. Now, why am I telling you that? Because I'm trying to show you that the pH, it measures the concentration of H plus ions, of the protons. And I will explain to you what's the difference between concentration and acid strength. Okay. So, imagine we have, like I said, we have 2 cups. Like so. And one of them has HCl with water, and one of them has ethanoic acid with water. Now, however, they are both at the same concentration of 1 molar. They are both 1 molar acids. You don't need to know molarities yet, but the point here is that they are at the exact same concentration. HCl and ethanoic acid are here at exactly the same concentration. They are, of course, dissolved in water of the same volume, giving you the same concentration. And what happens there? In HCl, we have all the molecules splitting into ions. And I will mark those in red. So we have 1, 2, 3, 4. So we have 8 molecules. Just to show you the point, we have 8 molecules and they are all red because they all split into their ions, producing protons. However, for the same concentration of ethanoic acid, now we have a mixed bag. Some of them decide not to split. Only some of them actually ended up splitting. So here we also have 1, 2, 3, 4, 5, 6, 7, 8. We also have 8 molecules, but only 5 of them are red. Therefore, we have less protons in this one compared to this one, despite concentration being the same, because this is a weak acid and this is a strong acid. And because this one has more protons, clearly, then its pH will be lower. And here the pH will still be acidic because it's an acid, but it will be higher compared to the strong acid. However, this is only true for situations where the concentration is the same, because that's different. Concentration is how much of the acid molecules we have there, whereas acid strength is what the proportion of the molecules end up splitting into their corresponding ions, rather than how many molecules there were to begin with, which is the definition of concentration. Okay, so let me show you that. Again, we have a similar situation. We have 2 cups. 2 cups. And in one of them, we have HCl again. And here we have again ethanoic acid, CH3, COOH. Okay. And what are we doing here? We have water, same as before. However, we have 1 molar HCl. However, here we have 2 molar ethanoic acid. So we have higher concentration of ethanoic acid compared to hydrochloric acid. And what happens here? So here we have exact same situation, 8 molecules like so. And they're all red because they have split into their corresponding ions, giving us protons. However, what happens here? We have twice the concentration. So here we have double the total amount of molecules. So here we have 3 green ones and 5 red ones. So here we have 6 green ones and we have 10 red ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here we have 10 red ones, and here we have 8 red ones. So here we have 8 molecules splitting into the ions giving protons. Here we have 10 molecules giving protons. So despite this acid being weaker, because we have increased its concentration, actually the ethanoic acid pH will be lower compared to hydrochloric acid pH, purely because we have more molecules to begin here, and even though not all of them have dissociated, the ones that did ended up giving us more protons than the ones in HCl. So that, guys, is the difference between concentration and acid strength. Acid strength just tells us how much of what the proportion of those molecules that we dissolve in water will form protons. However, concentration tells us how much of those molecules we dissolved in water, how much we watered down that acid by. So concentration will tell us how many molecules we have to begin with, and acid strength will tell us how many of those molecules will actually go on to give us protons. So this is it for today, guys. I hope that this video helped you immensely. I really appreciate, guys, you watching this video. I always appreciate, guys, when you watch these videos. I love doing this, and any feedback I would appreciate any feedback in the comments. If you like this video, give me a thumbs up. And if you have any questions, just shoot me a question in comments. I'm more than happy to help you out, guys, with anything at all. Thank you again, and see you next time.